Okay, in this video we're going to look at second derivatives, which means differentiating twice. Okay, but if we just look at this graph here, we have a graph x squared plus 2. Okay, so there's our function, x squared plus 2. And here is distance, and here is time on our x and y axis. Here's our function here. So that function will give me the distance after so many seconds. So if I want to find out the distance the object is after travelling after 1 second, I'll put 1 in for x squared. I get 1 squared plus 2, and I get back out 3, which if I just draw this line up from 1, I'll get back out 3 here. Likewise, if I put in 2 for the time, so after 2 seconds, so if I put 2 in here, 4 squared plus 2 squared, I get an answer of 6. If I draw a line up from 2, I get out 6. That means this object, after 2 seconds, is after travelling 6 meters. After 1 second, it's after travelling 3. Okay? So, in this function here, it's kind of a distance function. It allows me to put in a time, and it spits me out the distance the object is after travelling. If I want to find, so we'll just say distance there. If I want to find the speed at a certain time, okay, then we'll be looking at rate of change, which means we have to differentiate once. So if we differentiate this, we'll get f dash of x equals undifferentiated 2x. Alright, so if I want to find the speed after 1 second, I put 1 in there, 1 in for x, and I will get 2 1s are 2. If I want to find the speed after 3 seconds, I put 3 in here, it's 2 3s, 6. If I want to find the speed after 4 seconds, put 4 in here, and I get 8. Okay, so that here is a speed function, okay, after I differentiate. If I want to find the acceleration, what the acceleration really is the rate at which the slope is changing over time. And remember, slope, okay, is really speed. So any of you interested in cars and racing, the acceleration is really the rate at which the speed is changing over time. So it's the increase in speed, but what rate is that increasing or decreasing? So at what rate is the speed increasing or decreasing over time? Okay. To get that, right, to get anything to do with acceleration, or to get the rate of change over time, I differentiate twice. Right. So here's my original function, fx equals x squared plus 2, which was my distance function. When I differentiated that once, it gave me my speed function. And if I differentiated that again, and this is how I show it, just with 2 little dashes, differentiate that again, I get 2. So the acceleration in this is 2. Okay? And it's 2 for any part of the graph. So notice here, I have no x value to put in a number in this instance, right? So it's just 2. So that means the acceleration is the same from here all the way up to here. So the acceleration is the same for the whole graph. That mightn't always be the case, right? I might get if I had another graph, it might be like this. Okay, I differentiated twice, and I might get 3x. Well, then I'd have to put in whatever number here to find the acceleration. Okay, but in this case, no, it's just this. There's another way of writing this as well. So it's up here. So there's 2 ways of writing it. We looked at this. Here's another way of writing it. Okay, and the way we say that is d2y dx squared. Okay, but if you see that, you know it's to differentiate twice. Okay, thank you.